I've been doing data analytics, putting instruments on devices for a very long time. The problem it goes all the way back to the 90s. In the 90s, we started putting instruments on things with the promise that the equipment will eventually be able to tell you when it starts to get sick. We don't supply the robot, we supply the equipment that goes onto the robot. When you call another technician or another field service engineer for help, their first question will be, did you ask the AI? And if your answer is no, I'm going to instruct them to say, go ask the AI and then come back to me if it doesn't have the answer.
Even in AI, generally, or even in the large language model, they show a lot of intelligence, IQ close to human, but more on the tasks that has some of the mathematical reasoning, some sort of a language-based reasoning.
It's not just, I've got 15 years of experience with this equipment. It's, I designed the equipment and I saw every possible way it could fail and compensated for it, but I don't publish that. I don't talk about it.
Hi everyone, welcome to BetterTech Podcast. Today we have with us Joe Meloche, who is a Vice President at Atlas Copco USA. Welcome, Joe, to our podcast.
Yeah, thank you.
Thank you too. So to begin with, can you give us a brief introduction of yourself, your journey so far here, and also the business of Atlas Copco to set the context?
Yes, absolutely. I'm a degreed engineer, had been an engineer for many years and decided that failure mechanics were way more interesting. Making equipment that never fails is impossible, but diagnosing when it will fail has always been possible and exciting. So I switched jobs about 20 years ago, and I've never regretted it. So I moved from product design into the service industry, where we take care of the equipment, make it run as long as possible. And so that's my history. I've done this with two different companies now. I've been with Atlas Copco for about 18 years and doing the same thing for different product lines within Atlas Copco. So that's my history. As far as what Atlas Copco IAS does, the division that I'm currently with, is we manufacture assembly equipment for the automated assembly of sheet metal structures, such as a car body, battery box, things like that. So the technologies are self-pierce riveting, flow drill, adhesive application. Your car is glued together, and then the rivets or the welds just keep the car together while the adhesive dries. So we apply all of that. We don't supply the robot. We supply the equipment that goes onto the robot. So if you can imagine, the context is I have a PLC talking to a robot. The robot is talking to me. I have to do something physical. Then I report back to the robot. It reports back to the cell controller. So the context is always different. When we hear about a failure, that failure could be something inside our equipment that failed. It could be something that was driven by a failure in one of these other many mechanisms we interact with. The metal, sheet metal, is notoriously difficult to maintain tolerances on. So the puzzle is big, and it's new, and every day there's a new series of very simple things that we have to solve, and one really big one that's going to take a couple of days or maybe even weeks.
No, that's very interesting. That's like there's a word that I often deal and I'm taught with, this digital word, and then I always thought, okay, in parallel to all the digital word, there is really the more hardcore and physical world in machinery and equipments, and there's a lot that has to be done and is done around that part. Thank you for this nice introduction. And maybe we can start, because I think in one of your old discussions, you mentioned something about tribal knowledge. So for our audience, can you explain what is tribal knowledge, particularly in the context of field services, and why it is, let's say, crucial for the manufacturing industry?
Well, our equipment, of course, is designed by engineers. It's designed by some very talented engineers who know our industry, they know the expectations, and then we test it in a laboratory. But no equipment acts in the wild the same way it does in captivity. So once we put it into a context where it's interacting with variable sheets of metal, possible fasteners are different sizes, the robot might have some lash or something like that. Once these things happen, we need to solve them. And we'll come up with a unique solution to a unique problem that no one's ever seen before. The team of 3 people working on it will come up with it. Maybe they'll write a bulletin. Probably they won't. So unless you're sharing a beer with those people over the course of the next 2 years where they brag about how they've solved this big issue, it goes into their head and it stays there. It just disappears. If you share a fire with them, it becomes a campfire story, whether it's in a bar or an actual campfire, you'll hear about it. But if you're not in that tribe, you don't hear about it. Right. So if I have a group working in the Southeast and a group working in the Northwest, we'd like for them to talk about technical issues, but they might miss that one. And so it's gone forever when these people retire.
I see that, and that way it's really crucial for the manufacturing industry and basically any industry to keep
Yes.
that knowledge, right?
Yeah.
So can you maybe describe some of the key challenges that you see that service leaders they face when they are dealing with let's say the new equipment? Because there was I don't know, a paucity of a large amount of equipment, and things are probably moving so fast. So what are the key challenges that service people then or leaders have to deal with?
The problem with new products is that they're new. We've never seen them before. They're using technologies we're not familiar with. So when we get very, very good at something, it's time to update. And of course we have to do this. And we're very good. Atlas Copco is very good at developing new products or buying companies that make sense and then bringing their product into our portfolio and modifying it. So we're faced with new things every day, a new kind of field bus, a new kind of interface, a new microprocessor. These all have their own problems. They all have their own advantages, but they all carry with them a lot of baggage. So the biggest issue that we have with anything new is that we just don't have the experience with it. It hasn't been running out there long enough. And we learn what we can from the lab, but there's some tribal knowledge built in there too. There's some things that the engineers made a change on. They thickened up a section, or they added a little bit of extra code because they saw this problem, but that doesn't get out to the field. That doesn't get to our people. So when they didn't do enough thickening that section, or didn't add enough code or a delay, when we see that problem, we have to now take that, bring that back to them. Hopefully we find the right new product development engineer who wrote that piece of code, and then I remember I was having a beer with Sam and he told me that he made this change. It happens on new stuff as well. So it's not just, I've got 15 years of experience with this equipment. It's, I designed the equipment and I saw every possible way it could fail and compensated for it. But I don't publish that. I don't talk about it.
I see. So that's all possible, technical and human type of, not issues. But how can AI help in overcoming those obstacles for the new equipment?
Yeah. And we've been doing this, we've been trying this for a long time. So if you had asked me 5 years ago, I would have said AI is a terrible idea. We've tried different things. The way AI used to work, it was like a web crawler. You would put 1,000 manuals into some place, and then it would data mine those, and it would find, if you get an error code 112, here's exactly what the manual says. With generative AI, it gives us the flexibility to not only add that tribal knowledge, but it's begun drawing distinctions between seemingly disparate things. Some people call a motor, some call it a servo, some call it a drive. The AI has now picked up the fact that these are all the same thing, where a manual won't. So generative AI is now taking all of the information that we normally publish, that everyone has access to, information that we're getting personally from field service reports and quality concern tickets and tech support tickets and things like this. And it's drawing parallels between all of these things and making new suggestions on some things that we need to look at. They're smart, but they're not clever. So they won't make something up, but they will find that parallel and help us see that where normally we would be asking the wrong question.
That's very interesting. And you already mentioned some examples of general use of Gen AI for those problems. So could you share some specific example use cases for the very at Atlas Copco use AI, for example, to capture tribal knowledge, and how does it help you?
Well, we ran our first pass on this on a new piece of hardware that we were delivered last summer. And so we ran the trial. And so in this AI trial, we simply had the technicians use it for pulling manuals. If something needed to be changed, they would change it. And we found that there was, we had two, in a car plant, you typically have a left and a right, and they do the same thing, just the mirror image. Left side of the car is sealed and riveted the same way as the right. So the mirror stations weren't acting the same. One was working perfectly. One was faulting out every time the robot slowed down to a certain point. And the AI had no idea how to solve this. What we didn't know how to solve it. We went back to tech support, and eventually it took about 2 weeks. Now, this wasn't in production, so we didn't cost anybody any production time, but we studied this for 2 weeks. And in the process of this, I mentioned it to one of our people in the lab, and he said, "Oh yeah, there's an INI file, and it's full of flags. And when they issue the controller, they turn the flags on or off depending on which features you want. Just go into the INI file." And I said, "Oh, that's so easy." So I sent it to my guy. He found the flag. He turned it from a 0 to a 1. He saved it, and now both systems work identically. It's perfect. In the report back to the AI, he said, "There's an INI file that you need to correct." Right. So this happened again 2 weeks later. And the technician was right there, and he said, the two sides aren't acting the same. When the speed lowers to a certain point, it's not working. And the AI said, "There's an INI file. I don't know where it is." Because our technician hadn't told it. So it was extremely helpful because he was able to go directly to the file. And when you open the file, it says analog value 1 or 0. He changed it to a 1, saved it, life is good. So he solved the problem quickly, but it highlighted to us how important it is that, the AI isn't that clever. It's not that generative. We really need to tell it where the file is located, what flag has to change, and so on. So the second technician did that, and it went in and is now there forever. So someone has this problem in Japan, in Japanese, they can type in the problem, and it'll say in Japanese, "There's an INI file, and here's where it's located, and here's what you changed." So it was extremely helpful, and it was a learning experience to us. So we're brand new to this. Yeah. So it was really cool to see.
That's good. I think the good part here is that also okay, the AI offers something. The engineers or the people, domain expert, they work with it, and then over the time, AI also kind of learn from that, right? So now this experience is also part of this kind of tribal knowledge or organizational memory, right? And AI should be able to pull it out right quickly. That's really interesting. In general, what is your, in your experience, the kind of biggest misconception or hurdle when it comes to integrate AI into existing service processes?
I think the biggest misconception is you can just feed it all your documents and it does everything. And this is, again, going back, I've been doing data analytics and putting instruments on devices for a very long time. The problem goes all the way back to the 90s. In the 90s, we started putting instruments on things with the promise that the equipment will eventually be able to tell you when it starts to get sick. Right. So we put a bunch of sensors on some devices that cost like $5,000 for a device. We're not talking about $1 million MRIs here where you can build microprocessors into it and sensors and things like that. We're talking about valves and pneumatic pistols and stuff like that. So we began that, and with the promise that it would be able to let you know when it has a problem. And I remember I pitched this to the board of directors at my old company, and the vice president said, "Oh, great, now even the equipment can call in sick." And so it was a good joke around the table, but they expected it within the next 5 years, and it didn't happen. So what these instruments did is they sent all this information out. And so we at Atlas Copco designed software to be able to collect this data. And we use the tagline, "Your equipment is talking. Is anybody listening?" And so people bought this software and they got all this data, but then they looked at it and they said, what am I looking at? We can do statistical trends. We can do some minor analysis, but unless I have a room of 50 people constantly looking at graphs, we'll never be able to see when it's going to fail. So now we're listening, but we don't understand the language. We just don't have the capacity. Enter AI in the teens, 2000 teens. Now we have AI that can look at this data and it can do a million analyses of variance on a terabyte of information in milliseconds. And so it does this, but now it's giving us dumb information. It's saying things like, if you increase the pressure, the flow also increases. Well, we know that. That's just physics. Give us something we don't know. And then finally, now we've married subject matter experts to the AI. All right, so now we finally have humans who are teaching it these little idiosyncrasies, these small things that you can find, and it's a huge effort. When people volunteer to teach the AI for me, I make sure they understand you're going to lose some Saturdays. You're going to lose a lot of Saturdays because you have to go through every little thing that you've ever noticed and every change in these graphs that you believe is an issue that could spell out an impending issue, and you need to put it in there, and you need to tell it why. And when you do that, it can now do these heavy analyses. But it took 25 years to get here. And the biggest misconception is I can flip a switch and give it a My Documents link, and it does all the work for me. It could not be more different than that.
Richard, I think that you pointed absolutely, what you really hit on the head of the nail. And I see that there's like IoT revolution from 2015 and 2010, and this was exactly kind of an area where it was like, okay, now you have all the Internet of Things and Internet of Everything, for example, where everything is talking and telling, and sometimes the promises they actually went beyond the capabilities, right? And fortunately, just so recently, we come to a point where things could be like more trustworthy. And as you mentioned, maybe with the help of people, because even in AI, I mean, generally, like, or even with the large language model, they show a lot of intelligence or IQ close to human, but more on the tasks that has some other mathematical reasoning, some sort of a language-based reasoning. And once we go towards, still those equipment, the data, charts and plots, it's not yet there to get everything automated. It is probably still the best idea to make it more like man plus machine model, and then make those machines,
exactly,
do a better job.
The AI can't imagine that there might be a three-phase motor running right next to our system, and that might be where noise is coming. It can't imagine that, but we can, because we walk past it when we walk through these factories.
Yeah. Exactly. I think that's very important for leaders to understand, and this magic thing. AI will do everything. It's probably not. There is a big kind of due diligence that will always be needed by experts, domain experts, or by leaders themselves. Perfect. So yeah, and then moving on to particularly in the domain of Atlas Copco, when you implement AI systems, right, and then your users are technicians and service people. So how do you make sure that when you are implementing such systems, then they have a good user experience and understandable by people who are not really tech savvy?
I did a survey. And of my entire team, they landed in thirds. A third said that, wow, this is great. I can't wait. I want to teach the AI. I want to have everything to do with it. Then a third said, I'll use it if it's helpful, but I don't want to have to teach it or correct it. And then I had a third that said, I'm afraid of this technology. I want nothing to do with it. I saw the Terminator movies, but whatever the rationale is, they don't want to deal with it. So we're launching it only with the people who are very excited about it and want to teach it, because we're in the launch process now. We're about a month in of the big one. The trial was last summer on one product line. This is going on every product that we have. So we've begun, and we're only using the people who understand that it's not going to know a lot of stuff. It's going to know it's in the manual, but these are all people who have worked for us for 10 or 15 years, and they know that there are things that are not in the manual that it needs to know as well. So if we just ran it out to everyone, the people who are not interested in using AI would probably get on it, ask it some tricky questions just to prove it doesn't know anything. The people in the middle who will use it but don't want to teach it will use it until it makes a mistake. And then they'll say, oh, this technology's not here yet, I give up. But the early adapters, the people who are really interested in it, understand. We've had many, many discussions that it's going to be wrong, probably a lot. It's probably going to miss some things that you consider basic. teach it, and it'll never miss those things again. So that's how we're introducing it and rolling it out.
Yeah, that's very promising in a way, right? And I agree. Change management, there is always some sort of resistance, and I think this is something that is really a good strategy to prove it with the exciting people who are ready to take a change. And this is even true for I notice even from all the software engineers, even data scientists. I work a lot with the data scientists, software engineers, and I noticed that if you are like pushing AI, like I'm not going to use good Copilot,
Right.
you will find a lot of difference with the people who are actually using it and who are more open. They will take it and they will get the job done much quicker and in a much better way than even an expert who's resisting. So it has to probably go in a fashion with more accepting way. But just another topic, that is about the data. So, because it's very important, you're collecting a lot of data, and you already said, machines are telling something. So, how do you, or what kind of steps, you take to ensure the security and integrity of the data that is collected from, the field services?
That's a major concern of every customer who's doing data collection right now, is that when we take this data from them to do analytics for them, we've got non-disclosure agreements and things like this signed, but that it isn't enough. What we'll always do is we'll sanitize it. So anything with a station name, we'll change the station name. Anything with VIN number, model number, anything with a serial number, we take that off. Right. So the data is easy to clean from our database. So when I do an export to me for analytics, I get the date, the time, the pressure, the flow, the torque. I get all of those. I don't get the station number. I get the station number is like 1 or 2, not 433 robot 2. This is so that's built into our exporter. Is that you can choose things to not export. We have a cloud service that collects this data as well, and is now getting to the point where it can send you email warnings. That is an encrypted connection, an encrypted VPN that we use. With that data, it does store that information, but it never leaves the customer's portion of the cloud. So when I get an email, it says this station is having a problem. Would you like to see all the VIN numbers where this problem occurred? But that is held in a very secure environment. So of the two different ways to get the data out, one is just a pure cleanse. The other, we have a lot of encryption and protection. That's always vetted by their own IT departments. But that's a major concern. And when you can, say we have a car accident sometime in the future, and someone pulls the digital birth certificate of the body of that car, and it shows every bead of adhesive, every rivet, every weld, every flow drill that went into that, all they really need to do is find one that was a little on the low side. And they can say, oh yeah, here's the problem. People who don't know how the equipment works can blame that. So I get it. It's pretty important that in the interest of keeping everyone honest and making sure that we can really drill down and find actual problems and not invent them, the data has to remain the property of the user, the people who generate the data in the first place.
That's great to hear, because I noticed that this is also how I think digital work separates from the industrial. In the past, I used to work, like, for example, building, industrial commercial models. Not commercial model, but let's say industrial model for, detection of defects, anomaly detection. And one thing that is separate from the cat dog classification or large language model, our open source model is in open source. There is a lot going on. Okay, all the data on the internet is technically available to everybody to train the model, and all the big companies, they fairly or unfairly or in a good way, at the end of the day, maybe took an advantage of that. However, for the customer data, it's a lot more sensitive and a lot more, proprietary. That's good that, anonymization, decoupling, and also, limitation of data is applied on your side. Now, moving towards the future, so how do you envision AI evolving within the service sector, and particularly, I'll say, in terms of enhancing decision making and operational efficiency within the service sector?
We've fed a lot of field service reports into the AI so far, and we're feeding a lot of the problem-solving tickets and things like that. And what we're noticing, and this is just us in the process of doing this, is that there's a lot of repeated tasks that are done a very, very different way by each of the technicians. But each job takes a certain amount of time. So eventually, and probably pretty soon, we'll be to the point where the AI can look at all of the different methods used to install and commission this kind of piece of equipment, and then draw a procedure based on best practices over and over and over again for each one of the procedures that we go through on a regular basis. So we can streamline every process that we do just by taking this. The metadata that's calculated along with the actual problem solving data and use that for streamlining. In addition, everything we come up with, everything that we find, every new insight can go back to engineering. And with the way that I was just talking with my training manager this morning, he asked me the question. He said, a year from now, can I ask the AI what's missing out of the training manual for this particular device? And I said, yeah. And it'll give you 14 pages showing what needs to go in. It'll index it for you. It'll say in section 14.2, you need to add a bullet 5 that says this. So that also streamlines the process. The fastest way to solve a problem is to just get in front of it and solve it. The second fastest way is to not know the answer and go to the AI for it. Right. So if I can even eliminate doing that by adding things to the training, that further streamlines the process. So the future of this is the AI helping us get better at everything we do based on just it watching us do what we do.
So that means that if it's like I use it like, okay, doing things right first time, but even if it's not first time, at least with AI, you know that second time it is right because you have collected all the information from the first attempts of whatever, all people, and then what is really best. I think that's really kind of hyper, local optimization of AI across the processes, right? That's great.
Exactly. And these processes are portable as well. The way that we do something here is the same way we would do it in Argentina or Brazil. It's exactly the same, and it'll be in their language. So as it's optimizing and improving our procedures and improving our manuals, all of these manuals go back to the native language of wherever you're working. So what we do in the United States benefits all the other markets. What they do benefits us. So that's a further opportunity for improvement worldwide.
That's good. So now, can you discuss some or any upcoming innovation or project at Atlas Copco that aims to further bridge this gap between the human expertise and AI?
Well, the use of the big data is the next one that's coming. So we're currently using this to do problem solving and problem tracking and quick resolution when the field service engineer is in front of the equipment or even on the phone with someone. The next big step, of course, is that holy grail that we had been chasing around in the 90s where the machine calls you and tells you it's sick. That data is all there. Like I said, we started listening, didn't understand the language. The AI understood the language, but it doesn't understand the dialect. Our people have taught it the dialect, and it knows the language. And now we can use this to be able to take that big data and send a purchase order for the part that will be needed to my ordering department, and then to my field service engineer, schedule them to be out there on Wednesday to be able to go and install the part. So the part arrives, the technician arrives, they tell the customer, oh, you have a problem over there, we go fix it. And that's the future of our equipment. And it's that technology has been here for things like, mentioned the MRIs, compressors, things like that earlier. But these are $1 million machines, and ours are not. This is a $6,000 applicator it's going to tell you needs to be fixed. So we don't have the flexibility of putting all this instrumentation in there. We're just going off what it tells us. So it takes something way more intelligent than our device to decide that there's something wrong. Not to mention that our context changes like crazy. There are different materials, different hardnesses of sheet metal, different thicknesses of sheet metal, dimensional issues, robot issues, PLC issues, and all that. So our environment, our context is much more complex than the context of an MRI. An MRI does one thing, scans people. Ours does multitudes of things. Materials change as the sun rises, the material gets looser and viscosity decreases and it flows more freely. And we have to constantly compensate for things like that. So that's the future. Now, we've done this on our DC electric tools. That's a sister division. It's actually the division I came to work for when I came to Atlas Copco. So we have something called Alternative Future. and that's what it does, is it takes us data from the cloud, does these heavy analytics, but it took a lot of human beings to teach us how to do it. But now I can call a customer and say, your $6,000 power tool, the gearbox is starting to go. So here's the part number for the gearbox. Here's how you replace it. So that's there. We need to do that for the heavy automation equipment. And unfortunately, my equipment is 20 times as complex as a nut runner. So it's a bit of a bigger hill to climb, but it's an exciting hill.
But that's also one of those exciting things, because often when I talk with the engineers or data scientists, and it says, oh, maybe LLMs have done everything solved, and I'm like, no. There is a lot beyond journal LLM.
Yeah.
There is complexity in the world. So thank you very much for having that for us, especially in general for science, to solve some of that. That's great. So yeah, it's really, I think, a very interesting discussion with you. So, but moving towards the end, maybe finally, what advice would you give to other companies or leaders who are looking to leverage AI in capturing and utilizing tribal knowledge within their service operations?
The most important thing that we've learned in this is that there's a lot of work. It takes a lot of work and effort to get the data together. You really do need to separate your team, the people who are very interested in it, very excited about AI. Get them involved first and only them, so that as it makes mistakes, as they have to correct it, they don't get frustrated and throw it away. I'll never use this app again because it was wrong about a calibration procedure. And make sure that you're tying your people in, right? So AI can look at lots and lots of information. It's a pattern recognition system. It does millions of analyses of variance all at the same time on multitudes of data sets. And it's really, really smart. It has no idea what any of this means. Not a clue. So you really need tie the right people in. Find SMEs who are super excited about the AI, put them in front of it, let them teach it. 2 months later, bring the middle group in, and eventually that third group, through sheer peer pressure, will start using that. And I say that because when you call another technician or another field service engineer for help, their first question will be, did you ask the AI? And if your answer is no, I'm going to instruct them to say, go ask the AI and then come back to me if it doesn't have the answer. So we'll get there. It'll be painful, but prepare for a lot of work. That's my advice to them, and include all of your smart people.
That's great. So that's great. So yeah, with that, I would like to thank you again for a very insightful discussion and a very open discussion, Joe. It has been really nice to have you on our podcast. Thank you again. Have a nice day.
Oh, thank you. Thank you for the invitation.